Okay, this is for you that missed the battery lab setup. This is a dry lab battery. What I need you to do first is print off the battery from the website, the dry lab battery, and then I need you to color the first page like I've got shown here. Now you don't have to use the exact colors, you don't have to use orange and blue, you can use red and yellow, doesn't matter. But the two colors that I've got, orange and blue, that's what you need to do with that area. So whatever two colors you choose there. Then the voltmeter is a different color, and the generator a different color, and the salt bridge is a different color. Okay, do that, pause this. When you get that done and cut out, turn the video back on. All right, for the next part, I need to take you through setting up the first battery. There's a couple of acronyms that you need to remember. One was from the video that hopefully you watched 2 minutes. It's LEO, the one that says GER. LEO, meaning loss of electrons, is oxidation, and GER, that gain of electrons is reduction. There's 2 others that I would like to talk to you about, and they are N-ox negative. That means anode is the oxidation side, and it's the negative side of the battery. And red cat pots. Red cat, reduction. Cathode is the positive side of the battery. We'll use those here in just a minute. Now the first one that you've got that comes out, it says nickel cadmium, which takes cell, and you're going to paste these down below. The first thing that you need to do is look at a standard potential reduction table. And I've got one right here. If you don't have one at home, just go ahead and Google it. You should be able to bring one up. College Board has one, so you go College Board reduction potential table, and that will come up really fast. You want to find the 2 that we will be working with. Now the 2 that we're going to be working with are down here, nickel and cadmium. Now, nickel is above cadmium. This is a reduction table, so because nickel is above cadmium, nickel gets to be reduced, and cadmium has to be oxidized. Now, reduction and oxidation have to take place at the same time. So, because they have to take place at the same time, one of them has to be oxidized and one of them has to be reduced. You have to think of it sort of like a wedge. Somebody has to be green and somebody has to be wide. So here you've got nickel, and it's going to be a negative 0.25. So right now, I'm going to put on a reduced. Oh, I forgot to do one thing for you. Let's put our labels here. LEO for oxidized, and GER for reduced. LEO on the left and GER on the right. We're going to put those in. And we just decided that nickel is going to be our reduced. So on the reduced side, we're going to look at nickel, and we're going to get the nickel electrode. So you can find the nickel electrode right here. And we're going to put it on the reduced side. Whoops. This is the electrode, the tall skinny one. And we're also going to need the nickel plus 2 little square. That's going to go in here. Now, nickel, like on the chart that we just saw, will have an equation that looks like this. So that's the equation I'm going to put there. We also found that nickel was a negative 0.25 volts. Okay, the other one that we were working with was cadmium, so I'm going to find cadmium's little half thing here, and its electrode. Alright, we're going to find cadmium's equation. And from our chart, cadmium was below nickel right here, and it was set in negative 0.4, but we have to reverse this equation, flip it, so we're going to change the sign to a positive point, 0.40 volts. Now all I have to do is add these 2 volts together, and they give me my overall voltage, which would be 0.15 volts. Now, because it has a positive voltage, we're going to need a voltmeter. So we're going to put a voltmeter up here. And we've got to connect our electrodes to make the circuit. So we're going to connect one here and one here. And you'll notice here that the electrons are being given off on this side and we're taking them in on this side. So we're going to show that the electrons are moving this way. And you'll notice saying from earlier, N-ox is a negative experience. So over here we've got oxidation. This is the anode. And this is the negative side of the battery. And you have the red cap off. This is the reduction side. I'm running out of room that says reduction. This is the cathode. And this is the positive side. You're going to need to write those on both of all of your batteries. The next thing that we need to complete the circuit, because we don't have a completely a circuit or circle, we have a space here, we need to connect this with a salt bridge. And in the salt bridge there is KCl, or potassium nitrate, or potassium sulfate, in some kind of solute. Okay, so then what we're going to do is, this is giving off cadmium, and cadmium is becoming Ca plus 2, so it's going into solution. Because it's going into solution, this electrode is going to become smaller. Over here, nickel plus the 2 electrons that came across are going to make nickel, and so this electrode is going to grow. Alright, now, when this electron grows, the nickel is coming out of solution, and so we need to replace it with the positive side of this, which happens to be K+. So K+ is going to move this way. This is called a cation. Now, over here, we're adding more positive in the solution, so to balance the charge, the Cl is going to move this way, and that's called an anion. Alright, this is what you need to set up for all of them. Now the next one that you're going to be using, down below this cadmium nickel is a rechargeable battery. And so this is what we've done right here is the battery as we use it. And then we plug it into the wall. And so we're going to use the nickel cadmium underneath here. And we're going to switch it around. So we're going to put a generator in here, and we're going to set up the same thing that we have up above, except nickel's going to be on my left this time, being oxidized, and cadmium is going to be on my right, being reduced. And I'm going to force the reaction that way. So the charges will, with cadmium, it will be a negative 0.4 voltage, and with nickel, it will be a positive 0.25 voltage, so the overall voltage will be negative 0.15. This is my only generator. Now there's 2 types of batteries. There's a voltaic, which is up here, and the electrolytic, which I have right here. The electrolytic, you get a negative voltage. The voltaic gives you voltage. So think of the electrolytic, I have to plug into electricity to make it go that way. Voltaic gives me voltage. Okay? Good luck getting the next 2 done. Oh, let me just show you really quickly. The next one on the second page is hydrogen and zinc. So if you look at hydrogen and zinc on a chart here, zinc is below hydrogen. Because it's below hydrogen, zinc is going to be reduced. Sorry, it's going to be oxidized. And hydrogen gets reduced. The last one is copper. Please use this one, this copper right here. This copper right here is above the hydrogen, which is right here. So copper is going to be reduced, and the hydrogen is going to be oxidized. So go ahead and set those cells, and we'll see you in class.